And now, another episode of Slack Chat.
Dum, dum, dum.
Do you know what, Phil? It's actually
Yes,
going to be episode 16. And since we started the podcast, when did we start the podcast?
earlier this year, March, April.
Since we started the podcast this year, there have been more or less 1,350 people that have listened to it, or listens, I should say. I haven't got more of the analytics on there, but
That's a good number.
yeah,
It's a really
I'm kind
good.
of surprised in a way because we had no idea who would listen to it. It could have been just us or
Absolutely,
just
yeah.
me
No, it's
editing
just
it.
two guys driveling on about Slackware Linux.
That was the thing. I had no idea whether anyone would actually be interested in how you think about this stuff and how you do this stuff in open source. Quite a few people that listen, yeah. Cool. Hello.
Hello, everybody. Some of the times when you're describing technical things, sometimes I go back and listen to it a few times because I never understand the first time. The first
Oh,
time
so it's
Google.
you're inflating the numbers. Is that what it is?
No, because I don't do this a lot. But you hear something, you think, right, I'll go to Google, I'll find out what that is, and then you hear something else, so you Google a bit more. So then, when you've understood what you're actually saying, and I'm able to assimilate it and understand it, it's maybe the fourth or fifth time I've heard it. So that's how I work anyway. But I don't go back to the beginning. I just rewind it a little bit and listen to it again. But I think it's good. It's something to talk about, and hopefully it's interesting not just to us, but other people as well.
So yeah, this is the Slack Chat podcast, and it's ostensibly about things to do with Slackware ARM, but that's because I'm the developer and creator of the Slackware ARM port of the Slackware Linux distribution, and Phil is the maintainer and developer of the SAPI project, which enables you to put Slackware ARM on a Raspberry Pi more easily than you would have done otherwise, because I don't support it, and Phil does. So he's taken up that gap there. Yeah, that's why we'll mostly talk about Slackware ARM on here, but we tend to just talk about other things as well, really. What was on your minds this week then, Phil?
A particular problem a friend of mine had. I'm not going to mention any names because I know he listens to this, but he done a minimal install of Slackware ARM on his Raspberry Pi. Then he realized he needed to install some packages, but he hadn't installed package tools. So I learned how to do that. And I'm amazed in the 8+ years that I've been using Slackware ARM, I actually didn't know how to manually install a package on Slackware. It's a little bit late in the game, shall we say, but I learned that today.
Okay, cool. When you install Slackware, you do need to install package tools, because if you don't, then you can't manage anything. And likewise, you should not delete varlog packages or varlib pkg tools either. If you do that, you'll delete the package database. And the problem is with that is then you've got an unmanaged system, because if you want to upgrade to the latest version for security or a bug fix or something, then you really can't do that because there's nothing to keep track of what's installed on the file system. I mean, what you could do in theory, although this, oh no, I'm not going to get into how you could bail yourself out of package tools, to be honest. It is possible that you could do something, but it's far easier just to install package tools and make sure you leave it, and you can manage your system like that.
That has always been, whatever I install on setup, package tools is one package that I would never leave out, for the reason that I use it all the time. I use it absolutely every time I log in anywhere, because you know what it's like when you're developing software. You're always installing packages, removing them, exploding them, doing all these things. And without package tools, I'm stuck. So I would never install Slackware ARM without package tools. I'd be absolutely up the creek without a paddle. Well, I wouldn't actually now, because I came and said, how do you manually install a package? And you told me. So now I know. Thank you very much for that, Stuart.
It's all right. Well, that's the thing about Slackware. The distribution orchestration system, which includes package tools. So when I say the distribution orchestration system, I mean the tool set that allows you to control the operating system, which is Slackware. For example, Firefox is not Slackware. It's a package called Firefox and all those kinds of things. So I mean the actual Slackware structure itself, because those are written in shell script, it means that you can pretty easily see what it's doing, and therefore you can get in there. That's how the SlackTrack program that I wrote, that's in the D series of Slackware, that does the same thing. It gets inside the package system and changes things because it's easy to do. And as long as you keep the same structures and you don't mess stuff up, it's okay. Yeah. So you can easily see how to do that inside the shell script. And all you really need to do to install the package, I mean, the most basic sense is just run tar and tell tar with the -C option to dump it into the / into the root directory.
Right.
You just unpack it basically into the root directory, and then you run the install/do inst.sh shell script. You just run that. That will create symlinks or whatever the post installation script does. Yeah. There's a few things it can do. Sometimes there are other post installation setup scripts, like I think GPM has one about how you want to configure the mouse or something. There's some other ones as well, I can't remember. I'm talking about the ones when you finish the Slackware installer and they start walking you through a few setup pieces, those kinds of things. Generally, you can just run the install/do inst.sh script. Yeah. There's probably some other stuff around there, but basically, I only told you to do that to install package tools itself, and then I told you to reinstall package tools using package tools to clean up any of the stuff which I've forgotten that you need to do manually. Easier that way.
Like a dream. It's absolutely perfect. He's up and running now, and that's what he wanted. I mean, knows better for next time. I'm not aware how experienced he is in installing Slackware, but I know it's something that he hasn't done a great deal of. And I think when you read the instructions and the documentation, it does actually say recommended full install. Mm-hmm. I don't know how many times I've said that to people, but there it is in the README. Recommended full install. Mm-hmm. It even says it on setup when when you're installing, and it says full install or recommended. You can't blame the developers for not making it kind of clear, because it is there. So I don't know why somebody who wouldn't be that experienced in installing Slackware would go for an absolute minimum install, because you want the full toolbox to work with, don't you? You want the whole playground. You don't just want one swing.
Well, it depends, right? So when I install Slackware for my desktop machine and when I install the build machines, because Slackware, it is, as you say, the recommended installation is to install everything. I'll talk about that in a moment. But that's also the case that when Slackware is built, all the packages are built on a full system. So that means that you'll end up having, for example, the other day, CMake has been upgraded in Slackware Current, and it now, as I found out, uses Brotli, which is that's essentially a compression library that achieves better, I think pretty like 30% better compression rates than gzip, for example. So it's used in HTTP on web to improve web performance and stuff. Yeah. But anyway, so I discovered that CMake now needs Brotli. So my build system panicked, so I had to go and get in there and fix it. So Slackware is built on a full system as well. So that means that these packages are going to end up having lots of dependencies. So it could have been, for example, at least when I used to use Red Hat many years ago, I would install certain packages, but because it has a dependency resolution system, I would say, for example, I want to install Emacs, and then it would include all of the libraries or the other packages that Emacs depends on, and that's that. And I don't need to worry about any of it. Slackware doesn't do that. So you will end up with quite a few broken packages. I mean, for example, with PHP, I think you need, or at least you used to need in Slackware years ago, you need some of the X11 packages, or the X11 packages, because PHP picked up some X11 stuff when it was compiled. So Slackware doesn't have that dependency resolution, and there's no point in talking and getting into that. I mean, it is that way, and so doing a full installation is recommended. But that said, you said that you want everything. I don't, for example. So my server that runs Slackware, I do a very minimal install. When I would pare my system down, I would go in and I would manually select things. And then if anything did break, there was a missing library, I just find out by looking at the Slackware manifest which package owned that library, and then I would install that package as well, and then that would usually fix it. And then what I do is I just kept a list of which packages were required, and then just made sure they were installed the next time I reinstalled a machine for that. So yeah, if you do want to pare things down, I mean, it's just that when you do, you need to put some work into it in order to use Slackware.
It's funny you mentioned scripting. Now, over the past 5 days, I've put a tremendous number of hours into rebuilding the SAPI build process. Now, one of the things that I've never talked to you about is the order in which you do things and why you do them. We had a chat earlier where you said the project is the build process and the packages are the byproduct, and that I couldn't put it better myself. That is exactly how I look at the work I do, because the packages are going to get built anyway. The important thing is the build process, how it works. It's got to be like clockwork. And I just wondered if you obviously do, or else it wouldn't work as well as it does. But how much time and effort have you dedicated to the build process, and why do you order the things the way that they're ordered?
How much time? I don't know, to be honest. I know you asked me a while ago why, because I at one point called an end to developing the Slackware ARM port because it just took too much time. It just turned up into an admin job where I was just updating scripts, build scripts and stuff like that, versioning. I mean, that's not particularly interesting. It's just maintenance for no particularly good reason. So there's not an interesting way to spend some of your spare time. But because I still actually like the actual project itself, I get a lot out of actually learning, because you continually learn things. Yeah. Often in order to fix things, to be honest, but also sometimes just bring on a new piece of hardware and figure out how to integrate it and things. But it just started to take too long, and then started working on it. And I was like, oh yeah, quite like working on this actually. The other reason was because the Slackware ARM, the old ABI, which is what Slackware ARM 14.2 uses. It's the old ABI, the application binary interface. Yeah. So which is incompatible with the ABI that the hardware floating point port uses, which Slackware current is. So those things are basically completely incompatible. And the old ABI, no one supports it anymore. No one runs tests, no one builds anything on these old machines. Things will stop building. So there's no point in me maintaining it. I put it aside for a while and I thought, actually, I suppose I could build a hardware floating point port, because everything was already up to date when I ended it, and the development process in Slackware had slowed down a bit as well. So it was still pretty much in sync. Doing some stuff at work at the same time to do with DevOps and continuous integration. And because I know I've got a pretty good insight into how the other distributions do their build system. I know what needed to be done. I just hadn't built one. And I didn't want to use anyone else's build system, because that means I'd have to learn someone else's stuff. Yeah. And it wouldn't be any fun anyway. I don't want to learn someone else's build system. I'll write my own. I've got a pretty good idea of how to think about how to structure it. So I just sit on my exercise bike and then come up with the ideas. Yeah. I just plan the whole thing out in my head and then just start scripting some code up. And because I didn't have time to write the whole script anymore, I just write a big chunk of it and just leave it. Come back the next day, write another bit. And then over the course of time, start putting it together and made the build system as it is now, which is basically automates everything. The build system, I have no idea how many hours I've spent on it, but that's what I meant when I said that Slackware ARM had changed for me from being working on the distribution as it used to be, because I was porting it. Everything was brand new. There was no ARM port of Slackware. There was nothing. Yeah. So I ported the installer, made quite a few changes to that, built the kernels, got all the patches from everywhere, fixed stuff, everything. Then once I'd done that and got the distribution working, I'm like, well, I'm quite happy with what I'm supporting. So Slackware ARM project for me became the build system. So the actual packages that came out were just the byproduct of my new toy. And now it's kind of going back the other way again, because I've still got a whole list of enhancements for my build system, but they're not annoying me sufficiently enough that I can actually spend time and go and address them. So now I'm kind of back to looking at making a few changes, some of the things I want to do in the ARM port once I've got time. Yeah. Did I really answer your question, by the way? I think the answer is I don't know.
It doesn't go into enough detail.
Enough detail. Are you
Yeah,
joking?
I want more detail. I want details like the biggest problem you ever had and the time it took to solve it. Interesting things of that nature, because I've got long list of things
Oh,
that problems that I've come across that I've just taken days, sometimes weeks over. Like you said, you just leave it because there's a problem that you can't, or hurdle that you can't get over, and you keep
okay.
going back to it until there comes a time
Yeah.
when you solve it.
I honestly don't know. I mean, it's been like 18 years, so there's been
Yeah.
uh, there's quite a few things. I mean, the most recent one was basically getting Firefox working,
Oh yeah, I
and
remember
I
you
have.
mentioning that.
I got it compiling after fiddling around with changing a Rust architecture, which I learned something there as well, actually, I've got to say,
Yeah.
although
I
I'm not
can't
sure how
remember
useful it
what
is.
I can't remember what you said was the problem. Remind me.
This was to do with this trust thing, where this whole trust thing came from in the previous episode as well. But basically, inside of Firefox, I spent absolutely, well, Firefox is one of the big ones, actually, to answer your previous question.
Yeah.
Firefox, just not just in this instance that I'm about to talk about, but in general, it's been a pain. It compiled years ago, but then they started. So this. I'll promise I'll come back. I'm just going to go on a tangent for a moment.
Okay.
This is one of the main issues in ARM, and it's always been this way. Is that, and it's understandable. Years ago, Firefox worked on ARM v5 or v3 or v4, at least really old. I would now class as classic ARM. It's just
Uh-huh.
ancient stuff. And Firefox ran on those systems, and the developers made it work. But this was in the days when there weren't that many ARM devices. There was lots of ARM v5 around, and that was kind of it. But then when ARM v7s came in, and ARM v7 was used in Android, the smartphones,
Uh-huh.
then of course the Firefox developers are developing it for the things that people are really running it on, that are actually fast, much faster than these old ARM v5 things. And so that means that when they're building Firefox, what do? You take advantage of the hardware that you've got, which is ARM v7, which has more support for, well, for a start, floating point, some graphics stuff and other things like that, that simply just isn't in the older devices. And so, of course, that's what they use, because you use the best available. That's what you're
Yeah.
supposed to do in those jobs.
Yeah.
But the problem is with that is that they don't then have generally other code paths that supports older ARM hardware that doesn't have those new CPU features. What tends to happen is, even if that was the case, at some point, because no one tests it anymore, things just don't work anymore
Right.
on the old route. It is just normal. There's no coverage there. I ended up finding hacks for it, and then managed to get all that stuff working. I took it out of the tree and then put it back. And then stuff with neon instructions as well for ARM v7. Some of them did, some of them don't. Eventually, it stopped compiling because it ran out of RAM. And so then I had to start investigating how to make LD, the linker, work with less RAM. And that took ages, but I learned quite a bit about that as well, and switched to a different linker, to the gold linker with these different options. And then that stopped working. Firefox stopped building, and it got stuck at the linking phase. And then the guy on Linux Questions forum reported that Firefox wouldn't compile. And he was right, it doesn't compile with CLang. It still doesn't. At least it doesn't on Slackware ARM anyway. I basically thought I'd exhausted what I could do with the GNU tool chain, and thought, I'll just try CLang. It didn't compile either. So I spent ages changing the Rust architecture to try and work around this silly bug, which I would have had to have patched otherwise, and then maintained a patch for God knows how long. Is this too much detail? Let me know.
No, carry on,
This is
please.
actually how I process
No,
things. I think this
this
through
is
in
interesting.
advance.
This is really
Right.
interesting. Yeah.
Basically, what the guy had said on Linux Questions forum is, if you try to compile Firefox, and if you try to do it now on Slackware ARM, it will tell you that the Rust target triplet, it doesn't exist, and blah, 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 blah. So I recompiled it so that it did exist. I could actually hack Firefox to just stop complaining about this. If I do that, then I'm committed to actually maintaining a
Yeah.
patch. And given that I know how these code bases can change so dramatically, that would spend ages maintaining a patch, which quite frankly I have no interest in doing. It's just not on my roadmap whatsoever. It's easier just to change Rust so that Firefox works with it. You just, make that integrate properly.
Right.
But then I found that it still didn't compile. It was missing a header, and I thought, oh, goodness me, I'm still going to have to hack it. So I thought, I know, let's go back to GCC route, because it does compile. It just gets stuck at the linking phase. So I was like, okay, I've been through this problem before. So then I started researching that, changing some options. I realized that the Slackware build script for Firefox uses its own built-in JPEG library. At least I think it does. So I would do things like use the system JPEG library, one of those types of things, because that way it doesn't need to include more code, so it should be smaller. So I started fiddling around with the options and changing the linker flags again, and finally managed to get it to build. So it actually builds again with GCC, which is brilliant because, I'll get to answering another part of your question in a moment, it's brilliant because it uses my distcc cross-compiler toolchain platform, which actually speeds up the build process well over half. And that's one of the main problems with ARM, actually. So the reason why it takes so long is because it takes so long to fail. When you start building something, if it fails quickly, that's what you want. That's what Mark Zuckerberg says, fail fast. The reason you want to fail fast is because you save a lot of time waiting. And it's as simple as that. That's always the problem with ARM. Because the CPUs are slower, I simply wait maybe 2 days before Rust fails to build, or a day before Firefox fails. So it means that it just takes a lot longer than, right, let me hack this, let me try that, let me hack this, let me hack that. Oh, what about this? What about that? That's a hacking approach. That's what I'm doing. It's very rare that I would actually go in and start looking at the source code and go, right, what is this thing doing? Because you don't normally need to do that unless you're really trying to integrate it in a special way inside of Slackware. And generally, it's just there's some missing header. You need to go and tell it where the header is or something like that. And you can just make it, if this software builds on other distributions and they haven't patched it, then it means you just need to hack it or to make it build on Slackware. It'll work fine. You just need to prop up, tell it where to find things. And there's a few other things around that. But yeah, one of the main problems is actually that it doesn't fail fast enough.
Now, I can definitely say in the SAPI build process, there is a directory that I use. It automatically loads patches into the kernel as and when needed. And I've only used it twice in the past 8 years. So patching, I don't do a lot of. For what I build, which is the Raspberry Pi flavored kernel and modules, I don't need to really worry about patches, although there are times when things fail and I see errors while I'm compiling. I'm thinking, oh God, I'm going to have to use a patch. I've spent the past sort of 5 days revising the whole process, because you might laugh at this. When I'm scripting, and it's always bash, I write in bash, everything's included in one script. So I don't know, if I needed to build a kernel and modules, I'd just write a script from top to bottom. It would be the whole process, everything included in the script. Talking to my mate Al, who runs FatDoc, and he said, no, you need to organize this so it's easier to maintain. Because if you can imagine, you have a variable that changes, and I've got 7 build scripts, well, 1 main build script and like 6 subscripts. I've had to go through every single script and modify that one variable. And he said, no, you need to modularize it and use an include file, which is like, it's a settings file that includes all your variables. Then you'll have another file with your functions in it. And I thought, oh my God, this, I've been maintaining this for so long. And every time a change needed to happen or some code needed revising, I did it. And I've hacked away at it for donkey's years. And it's all become a real tangled mess of biblical proportions. So it really did need sorting out. And I decided about a week ago to formulate a plan. And I don't know how you do it, but I do it in my head. And if it makes sense in my head, I can put it into motion. So I formulated a plan and I went ahead with it. It's working out really well, but now I don't have everything solidified and incorporated into one script. It uses includes and and other functions to help run it. And it is a lot more manageable. It's going to save me a lot of time in the long run. But the problem I've found is not the actual writing of the build scripts themselves, but the troubleshooting and fine tuning afterwards. I mean, it's taking days. You know, I rewrote the whole scripts in about a day and a half, and I've spent the other nearly 4 days testing them.
Right. Mm-hmm.
Yeah, it's going really well. One thing that happened yesterday, I was in the Freenode IRC channel, you know, the Armed Slack IRC channel.
Yeah.
Great set of guys in there, really good set of guys. And I was talking to Ponche, you know, Ponche who does the slackbuild.org website. Yeah, and I was just whinging about multi-disk and device management and having to use DD to create a raw image. And he said, use fallocate. So he gave me an example of a command that he used. And it was like fallocate option L, the size of the image you want, sort of 160M is the size of the boot partition for the SAPI installer at the minute. And then the image file that you want to use. And I thought, it can't be that easy. It really cannot be that easy. So I tried out this fallocate command dozens of times. I mean, literally dozens of times while I'm testing and building. It only takes about 10 minutes to build a kernel and modules. So, you know, I'm just repeating that process and further testing. And it's working out really, really well. There's no mathematics involved, because what I was doing was do you remember some days ago, and I said, I found the formula. Might have even pasted it to you, this mathematical algorithm for working out how many blocks of 64K make up 160 megabytes. But I didn't want to have to put that in every time, so I thought, why not have the machine work it out for me? But with fallocate, you forget the maths. Forget all that. You don't need to work out how many 64K blocks are in 160 megabyte. You just type the size of the image file you want. So if it's 200 megabytes, you type 200M. If it's 2 gigabytes, you type 2G.
Are you talking about when you do DD IF equals blah, 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 OF equals blah, blah, and then say block or BS equals the block size?
Yeah.
Right, but I don't think you actually need to specify that parameter when you use DD. It'll just dump it to the disk, spool it out to the storage device. So I don't think you need to specify. I think, if I remember rightly, the only reason you need to specify the block size is it's either to do with tapes, as in like, you know, magnetic tapes, and then if there's a particular, it escapes me now. It's in the DD man page, but there are reasons why you'd want to do it, but I think it's more around to do with the format of what's on there.
Back in the day, and I'm going back to like 2013, that was the way that I learned how to do it. And since that time, it's never changed. It's never needed to change because it's always worked. And you know the philosophy: if it works, don't fix it. So. It worked, and it worked perfectly, but it was hard work when it needed to change. And because they keep adding more and more into the kernel and more modules are appearing, the RAM disk that I create, it gets larger and larger, and therefore the boot partition has to expand exponentially with, you know, in line with the increasing size of the RAM disk. So I have to go. This is how convoluted it was. I have to go get my calculator out, because back in the day, maybe I'm making this confusing. In 2013, somebody put on the Raspberry Pi forum that blocks of 64K was the best block size to use for formatting the boot partition. And I'm thinking, okay, I'll go with that. And again, it's just something that's never changed because it's always worked. That's why I had to get the calculator out, work out how many. I usually increase it by 8 megabytes at a time. So I have to work out how many extra blocks there are in 8 megabytes and add that to the existing value.
But aren't you doing, I think I know what you're doing here. You're making one of those old style initial RAM disks where you
Yeah,
actually
yeah, yeah.
you have to set the size. You haven't needed to do that for years. Yeah, I was thinking, what are you doing? Yeah, that's how it used to be about
Yeah, but
10,
Stuart,
12 years ago. There's
that's
a much easier way
because
now. You don't need any of that stuff.
yeah, that's because back in the day, was how I learned how to do it, and it's never changed. So I'll get back to the story. I'm whinging at Ponche,
Oh.
saying, no, I'm tired of this. This is Patrick should ban this stuff from Slackware. And then I got the formula right, and I went back to him and I said, no, it doesn't matter. Forget what I said. It's working now. I'm happy. And then he said, try F allocate. And yeah, I tried it, and it really is amazing. It's changed the way that I now build the image completely.
Oh, okay. What I think you should do though is look at the Slackware installer build script, because that will show you actually how you can do it for kernels, because you don't need a fallocate either. You just need
Right.
let's find where it is.
And that was the which build script, sorry?
Trying to figure out how it's done. Where is it? Oh, here we go. If you look at Slackware 64-current/source/installer, so if you go to the Slackware 64 or Slackware 32-bit
Yeah.
source directory, you'll find a script called build_installer.sh.
Uh-huh.
Okay. This is actually the script that builds the Slackware installer. Originally, this was the one that I built for ARM. So this is how the ARM port got started. And then Eric used it for 64-bit. Nice bit of pedigree, this script. If you look through this script, you'll find a function called create init_id. And in there is actually how it's created. It's simply a find that pipes into CPIO. That's how you get your init_id image for the installer. That's where the file comes from.
Right.
I'm not sure if you're doing something different now, or maybe we're talking about different things. I mean, you still have to, in the case of ARM, you're supposed to TFTP boot that anyway. At least you are on the systems that I support.
Yeah.
So you don't put that to any kind of storage, at least not the local storage on the ARM box anyway. So yeah, that's how you can make an initial RAM disk.
Uh-huh.
The old style is the way you were describing. It used to be the code in here actually that did the old style. It must have been removed. Yeah. Well, listen, Phil, I actually need to go and cook dinner again. It's my turn today. We'll have to pick this up again on another time. We'll do it soon. Have you got any questions about it? Yeah, happy to answer them.
Yeah, great talking to you.
Cheers, Phil.
Okay, Stu.
Take care.
Bye for now, mate.